Okay, problem number 7 and 8. Okay? We have, if I jump off a bridge, then I will land in a lake. Okay? We need to tell what the hypothesis, what the conclusion. 2, we need to put it in logic symbols. Okay? Or symbolic logic. Okay? I need to know the counter example if it's false. Okay? So, first step, translate it into a symbolic logic. If, that is this guy, right? Oh, you can't really see that too well. If, right? And then. If, the 3 lines, and then the arrow. Okay? We'll determine whether it's a biconditional or something on the next one. Okay? But right now it's if and then. Okay? Then I'm going to take I jump off a bridge and I'm going to rewrite that into one symbol. What do you think of when you think of I jump off a bridge? J? Okay. I jump off a bridge. Fair enough for me. J. Okay? Then we're going to take I will land in a lake. Land in a lake. What do you think of? L. Okay? Fair enough for me. L. So if J, then L. If I jump off a bridge, then I land in a lake. First of all, what is the hypothesis? Yeah, if. If is the hypothesis. Okay, what is the conclusion? That's right. Then comes the conclusion. Always. If, hypothesis, then conclusion. Okay? What else? We need to know, is this true? Is it false? False. Is this always true? No. If I jump off a bridge, I might land in a lake. Like if I'm at Stillicum Lake, and there's a bridge that goes over it, I can jump off that bridge, and hopefully I won't die when I land on one of those pilings underneath the water, right? But if I miss it, woo, that was fun. Okay, so, alright, so yeah, that's true sometimes, but it's false also, right? Because in Tacoma there's a gulch, right? And if we jump off that bridge, we're not going to land in no water. Okay? We're going to land in maybe some mud if we're lucky. And it ain't going to feel good. Right? So, false. You don't always, if you jump off a bridge, sometimes you land on a street. Sometimes you land in a river. That's not a lake, right? Sometimes you land just in a bush. So, I mean, you got to come up with something. You could land in a bush. You could land in a bush. You could land on a street. You could land in a car. You could land in a farm. Wait, oh, sorry. Didn't mean to go a little, what is that called? Cat in the hat on you? Okay, so, but that's the counter example. Okay? Counter example. Okay? Alright. And that's all that they're asking. Very simple. Give me the symbolic logic, hypothesis, conclusion. Is it true or false? And then, why is it false? Give me an example. Okay, next one. The next one, we're going to go a little further. Okay? And I don't want you reading what I'm saying on the test, because I'm going to change it. I'm telling you how far we're going to go. We're going to go a little farther than we've ever gone. Okay? So, 2 things for sure. I want the conditional statement. I want the inverse. No. Converse. Sorry about that. I want the conditional and the converse. For extra credit, I want the inverse and the contrapositive. Okay? for extra credit. Okay? But you're going to at least give me the conditional and the converse, and then tell me, is it biconditional? Right? Does it work both ways? Okay? So, in this one, if two lines are parallel, if they're parallel, right? Then they do not, remember, not, the symbol for not. So you have if, you have parallel, you have then, you have not, intersect. They do not intersect. Okay? I'm going to expect this from you. You have to know these symbols and what they mean. Okay? So, what is that's the conditional, right? The con-D. The conditional. What I want next is the con-V. Right? The con-V is what?
If they don't intersect, then they're not parallel.
Yeah, if they do not intersect,
Then
then they're
they're parallel.
parallel. Okay? Is that true? And we're talking about Euclidean geometry, okay? We're talking about two-dimensional Euclidean geometry. So, is that true? If two lines do not they are parallel, then they do not intersect. Yes, that's true. Well, if they do not intersect, then they are parallel. Yes, that's true. In Euclidean two-dimensional geometry, that is true. Okay? What does that mean?
It's biconditional.
That means that it is a biconditional. Okay? Which means you can write parallel, biconditional, then not intersects. Okay? They are biconditional, and it works both ways. Okay? Now, extra credit says, hey, I want NV. I want the inverse. How do I write the inverse? If not parallel, then not intersect, right? Two knots cancel each other out, right? So then they intersect. So if they're not parallel, that means they intersect. That makes sense, okay? And then how do we write the contrapositive?
The backwards inverse?
Yes, you just invert it, right? So, or you do the converse of it, the converse of it. So it's if they intersect, then they're not parallel. And they should all be true. Okay? Does that make sense? All right. Good.